Okay, so we want to talk about dynamics and how do we solve dynamic problems. So this could be like a motor ramping up the speed of a fan or an electric car or any type of dynamic type system that we want to be able to solve. So dynamic systems are basically solving differential equations. Oh, let me try. So how do we solve differential equations? Well, we remember from taking our differential equations class that solving differential equations is kind of hard and there's only some specific cases that you can solve. So what we want to use is we want to use Laplace transforms in order to solve it. But we don't want to actually solve the Laplace transforms. We want the computer to do it for us. So we are going to use SIMULINK. So SIMULINK is designed to solve differential equations, and it solves differential equations in the Laplace domain. So in the Laplace domain, we're going to take a Laplace domain of our input and then run it through our system and then take the inverse Laplace transform of that to get out, and SIMULINK takes care of all of that. So what SIMULINK does is it takes some input, which is in the time domain, and it basically runs it through some system in the S domain. And then we are going to get our output back in the time domain. So that way we don't have to do all of the Laplace transforms and the inverse Laplace transforms. We let SIMULINK take care of all of that. We just have to take our differential equations and put them into the S domain. So then we're going to apply some arbitrary input into our system, which is in the S domain, and then we're going to get our output, which is going to be back in the time domain. So this sounds a little confusing at first. So let's look at a simple problem and walk through this process with a simple problem. So when you're trying a new problem, you want to do a problem that you already kind of know the answer to so that you make sure that you get it right. So we're going to do a simple RC circuit. So we're going to take a 10-volt supply. We're going to have a switch. We're going to have a resistor, and then we're going to have a capacitor. So we're going to do 1 microfarad, 1 kilo ohm, and we're looking for the voltage right here where this is switching at closing at time t equals 0. So let's use the information we know about RC circuits to know what the answer should be in the end. And so we get that VC is going to be equal to, and then we have it's going to start with 0 and then it's going to charge up, and so it's going to be 10 minus 10 e to the minus t over RC, which is equal to 10 minus 10 e to the minus t over 10,000. Oh, oops. E to the minus 10 to the 3t. Okay, so that's kind of where we're going. Okay, let's box this because we're not there yet. That's where we should end up getting in the end. But we're going to use our Laplace transforms to figure this out, and then we're going to use SIMULINK. Okay, so let's look at what this is. And so we take our beginning part, so our source right here, which includes the voltage source and the switch, that's basically going to be an input. So our input is 10 times a step function. Okay, so now we want to do our output. So we're going to look at the voltage and current in our capacitor. So we remember that I C of t is equal to C dV dt. Okay, so that is the current in the capacitor is equal to C times the derivative of the capacitor voltage. And we can do it the other way, and we have Vc of t is equal to 1 over C, the integral of IC of t dt. So we're going to use these equations to do this. So we're going to do a KVL around our loop. Okay, so that's going to be equal to minus 10, which is a step, okay, plus my resistor times my IC of t plus my VC of t equals 0. There is my KVL. Okay, so we want to put it all in terms of voltage or current. So we are going to convert all of this into our current. So we have minus 10 times my step plus R times IC plus 1 over C, the integral of IC of t. Well, we don't need the dt equals 0. Okay, so now we have to convert this into a Laplace domain equation. So we're still going to have our input. We're just going to leave that as a step because we're going to leave that as an input. And then we get the IC. And now let's go look at our Laplace transforms. So we want functional Laplace transforms. So if I look right here, here is a Laplace transform table. Okay, so my time domain function goes to f. If I have a constant, it's just a constant times it. If I sum them, they're linear. Okay, and then here is my derivative, becomes an s. And initial conditions, our initial conditions are 0, which is nice. And then the integrals become a 1 over s. Okay, so what we want to do is we're doing this integral, which is my function over s. So we get this is equal to a constant, 1 over c, times the integral of I. So that's going to be capital IC over s equals 0. So now we are trying to get our output, which is our IC. So we're getting all that together. So we have IC times R plus 1 over SC equals 10 times my step. Okay, and so then my IC is going to be equal to my input times 1 over R plus 1 over SC. Okay, and so now if I have my output is equal to my input times this block, 1 over R plus 1 over SC. Okay, so now we're ready to go to SIMULINK in order to plot all of this out. Right now we're just getting current. And then, we don't want to just do current. We want to get to this equation that we had up here was in terms of voltage. So now I want to get my voltage. So my VC is equal to 1 over C, the integral of I dt. So I am going to have my VC of t is going to be equal to 1 over C. Again, we have our integral, which is the 1 over S. So this times 1 over S times my input, which is my I of t. So then this is going to be equal to my input times 1 over SC is going to give me my output. Okay, now we're ready to go to SIMULINK. So we're going to go to MATLAB. Okay, and I can either click up here, here's a SIMULINK button, or I can just type in SIMULINK. And it pulls this up. And, I just want a blank model. So I'm going to create a blank model right here. Okay, and so lots of times if I just right click, and then start typing, I can get it. So my input is a step. So I just start typing step. Here is my step. So I double click on this and it has a step time. So we're going up at time 0. My initial value is 0. My final value is 10. Okay, and then let's go back to our picture. So then we're taking our input and we're doing a transfer function. So this is just a transfer function. So we're going to come back to Simulink and we're going to start typing transfer function. Oh, good, there it is. So then we pull it up. And so what we see here is this is of the form of s plus some value. So I have to come back over here. I don't want a 1 over s on the bottom. So I'm going to have to change this block to be, I'm going to have to multiply the top and bottom by my s over c, so it's in the right form. So this is sc over src plus 1. Okay, so we have to put in that form because I can't have a 1 over s, I just need an s. So it's sc on the top and src plus 1 on the bottom. So I come back over to Simulink, double click on this. The numerator is, so if I have a 1 and a 1, let's look what that does. Oh, okay, so the 1 and the 1 is, so one of these is the s. If I did, let's check and see what variables. So 1 and 2, I hit apply. Okay, so the second one is my constant. The first one is my s. You see, if I keep going, if I put like a 3 here, I can start to see the pattern. Oh, it won't let me do more on the top. Okay, well, we just want an s, so I'm going to make this a 0. And this one is my c, so this is 1e to the minus 6. And then on the bottom, I had a 1 and I had an rc. So this is going to be 1e to the minus 3 because I'm taking 10 to the minus 6 times 10 to the minus 3. I hit apply. If I make this a little bigger, then I can see what it is. Okay, so now my output, I want to display my output. So I'm going to be using a scope. So I hit scope. Oh, but before we do that, let's go back here. We wanted to do voltage. So now I'm going to take this one and multiply it times the 1 over SC. So I'm going to add in another transfer function to convert it back into a voltage. So go back to Simulink. I'm going to do another transfer function. Throw it in here, and then I want a 1 over SC. So this is going to be 0. SC is going to be 1e to the minus 6. I hit apply, hit OK. And then in order to wire these, I grab this little thing and wire it over to there. Okay. Now for this, I want to do 2 because I want to plot my input compared to my output. Okay, so, and I can come in here and add in a variable. This here is my voltage. This here is my current. Okay, and I right click on this to give options and signals and ports. I want to make the number of ports 2. Okay, because I want to plot my voltage and I also want to plot my input there. Okay, so now I can do my stop time. I don't need anything that long because I know it's only going to be about a millisecond long. And I hit run. And then when it's done, I double click on my scope and I have these 2 plots right here. I can zoom all the way out. Okay, I'm going to have to go a little farther. So I'm going to come in here and make this 10 milliseconds. Rerun it. So now you see that at time 0, my input jumps from 0 to 10, and then this kind of goes up like that. Okay. If I wanted to look at my current, I can come in here and add another scope. But this one I want to connect just to my current right here. And again, I run this. And this one shows that my current spikes up and then comes down. This is a little bit hard to see the jump up, so I can come in here and delay this a little bit and say I don't want to start at time 0, I'm going to start at 1 millisecond. So then you see for this one, you see at 1 millisecond it jumps up, and then this goes here. And then this one you see at time 0, I jump up to my maximum current and I decrease down. So this is how I solved my differential equation by having my transfer functions are in the S domain or the Laplace domain. My input is in the time domain and my scope is going to convert it back into the time domain. So my inputs and my outputs are in the time domain. My functions, my differential equations are all done in the Laplace domain, and then I can get everything to work and I can model these dynamic equations and do different things. I can do steps and ramps and sinusoid and any type of sum of different functions, and then I can do and subtract things off and do all of those type of effects using SIMULINK to be able to model our differential equations. And this is how we use SIMULINK to model dynamic systems.